Hello guys, so we left here last time. I gave you this question that describe the motion of the object at every point, and I'm sure you have worked it out. So at point A, I would say that object is moving from negative x-axis towards the right hand side. Why? Because if I calculate the slope of this point, then that slope will be positive slope. Yeah, so it is starting, the object is starting from a point on the negative x-axis, and it is going towards the positive x-axis, moving towards origin with a positive slope. That will mean that I will have a positive instantaneous velocity. At point B, I see if I draw a slope, then this slope is steeper than point A. So I would say that here velocity of the object is small, here the velocity is increased. So object started slow and then its velocity increased at a certain point, and here at instantaneous velocity of the object at point B is going to be greater. If I draw a slope at point C, what that slope would be, that would be a flat horizontal line. That would mean slope will be 0 and object will be at rest at point C. So at point A, object started towards positive x-axis, towards right hand side with a slower velocity. At point B, objects continue to move towards positive x-axis, towards right hand side, but its velocity has increased. At C, object stopped. And what happens at D? I'll calculate the slope of this tangent line, and I would say that this slope, because it is towards left side, it's tilted towards left side, the slope is negative. That means object is now moving towards negative x-axis, and at point E again I have a flat slope. That means a flat or a line. That means object would stop here, object stop its motion. Yeah, so this is the explanation or description of the motion. Here velocity is small, here velocity is increased. Yeah, and at all points we have instantaneous velocity because we have calculated slopes on a single point, right? So our discussion on the position time graph is complete for the moment at least, and now we will move on to the next part, which is the velocity time graph. So I already have collected some data on a motion, and it says that at 0 seconds velocity was 0, and then with respect to time velocity continues to increase, and in a certain interval of time velocity does not change. And if velocity does not change, that means we have a constant velocity. And then in the last 3 seconds velocity starts to decrease, and if I plot a velocity time graph, then that graph would look like this. Yeah, so now I want to calculate the slope of these lines. So let's say that I calculate the slope of this part, and as usual I'm going to calculate the slope by measuring the rise, and this rise is about 8 meter per second. So rise is 8 meter per second. And how much is the run starting from here to here? So run is 4 seconds. So time interval is delta t, which is 4 seconds. Now if I take the slope, then slope is rise, which is 8 meter over second, divide by 4 seconds, and look at the dimensions. These are dimensions of meter over second squared. Meter over second, we have 2 seconds in the denominator, so it is meter over second squared, and meter over second squared is the unit of acceleration. So acceleration of the object is 2 meter per second. So slope of the velocity time graph will represent acceleration. Yeah. So slope of position time graph represents velocity, and slope of the velocity time graph will represent acceleration. So acceleration of the object, so velocity is increasing in the first 4 seconds. Acceleration of the object is 2 meter per second. So here I would say that acceleration is 2 meter per second squared. What is the acceleration in this part? Here, starting from 4, 5, 6, 7, interval of 3 seconds. What is the acceleration? So this is a horizontal line. So acceleration is going to be 0. Slope of a horizontal line is 0. You cannot calculate the slope of a horizontal line, so it is 0. So you will say that here object continues to move with a constant velocity. What is that constant velocity? That constant velocity is 8 meter per second according to this data. And then at 7 seconds your velocity decreases very rapidly, yeah, and at 10 seconds velocity becomes 0, so object is at rest. So if I calculate the slope here, then the rise in this part is going to be 8 meter per second again, 8 meter per second. And what is the run? How much is the time interval? 1, 2 and 3 seconds. So but remember that here your slope is going to be negative because it is tilted towards left side. So in this part my slope is negative. So 8 meter over second divided by 3 seconds, so it is something around 2.6 meter per second squared. This is a negative slope. It is called negative acceleration. Negative acceleration. All right. So I'm going to describe this motion again. So object starts its velocity from 0. Its velocity continues to increase at a rate of 2 meter per second squared, at an acceleration of 2 meter per second squared. And in which direction it is going? This slope is positive. So I would say that object is moving towards positive x-axis, towards right hand side, and then its velocity becomes constant, slope becomes 0, so acceleration is 0, and then it starts moving, its velocity starts to decrease. You would not say that object is moving towards negative x-axis because your velocity here is still positive. It is still moving towards positive x-axis. It is still going towards right hand side. But the slope, negative slope, means that now you have applied brakes. So object is slowing down. It is losing its velocity, and at 10 seconds its velocity would become 0. So this is the description of the velocity time graph. Remember that for our course we are limited to the positive to the constant acceleration. We are not going to discuss average acceleration or instantaneous acceleration. That you will study next semester, of course, if you pass this semester. So velocity time graph is simpler compared to the position time graph, where you have positive x-axis and negative x-axis, motion towards positive side and motion towards negative side, right? Here you will calculate acceleration, positive acceleration or negative acceleration. Positive acceleration would mean object is gaining speed, its velocity is increasing. Negative acceleration would mean that object is slowing down. Now the other quantity, the other information that you can get from the velocity time graph is the distance covered. In order to calculate the distance covered, you will calculate area under the graph. So this is the total graph starting from 0 seconds to 10 seconds. And how do I calculate the area under the graph? I can divide this graph into three parts. One is a right angle triangle, this one. Another one is a almost rectangle, this one. And then I have a right angle triangle here. So from 0 to 4 seconds, from 0 seconds to 4 seconds, I have a right angle triangle, and the formula for the right angle triangle is 1 over 2 base times height. Base is 4 seconds, and height is 8 meter per second. Yeah, 8 meter per second, and that would give me seconds are cancelled with second, and that would give me 16 meters. What is the area of this rectangle? You can see that from 4 to 7 seconds I have 1 to 3 seconds, and so width is 3 seconds and the length is 8 meter per second. So it is going to be from 4 seconds to 7 seconds. I have 3 seconds multiplied by 8 meter per second, and this would give me 24 meters. Yeah, and then in the last part I have 1 to 3 seconds and 8. So I have a right angle triangle again, so I'm going to calculate the area of a right angle triangle, and that would be, so from 7 seconds to 10 seconds, it will be 1 over 2 times 3 seconds times 8 meter per second, and that would give me 12 meters. So what is the total area under the graph? It is 16 plus 24 plus 12 meters, and that would make 52 meters. So in 10 seconds, object has covered a displacement of 52 meters, and this comes out to be positive. So object is moving towards positive x-axis, right? So this is the discussion on the position time graph and velocity time graph. So in a velocity time graph, you calculate the acceleration of the object. Acceleration can be positive, acceleration can be negative. In this case, acceleration was negative, minus 2 meter per second squared. This means object is speeding up. This means object is slowing down. Yeah. So very soon you will get the next assignment, that would be about the position time and velocity time graph. Thank you very much. See you later then.